I have with me James Dow. He's a CTO with CSTechnology. James, thank you very much for joining us today.
Certainly.
James, what in your opinion are the top technological challenges in data centers that serve the financial services sector today?
It's really about the proliferation and the complexity of the workload that's in the data centers today, all happening against the backdrop of 40 years of embedded code. Finding the right command and control structures in place for all that is going to be really critical for us, because long gone are the days where one business process equaled one application equaled one server. It's a business process lives on hundreds of apps across thousands of servers, and stitching all that together. And then as we try to evolve that through new computing platforms, new methods of delivering our business process, finding the business process in the data center, being able to track it through, manage it, bring it up, bring it down, put changes into it, and still maintain some level of reliability and service is really going to be the key issue. And there's a lot to that, because that goes all the way down to the M&E level with the watts, the KVA, the BTU, networking, the servers, what we're doing with virtualization. It's what is the picture that stitches all that together, and ultimately we have to deliver the business, not fancy ways to do servers.
What are the top, if we talk about the business side of it, what are the top business challenges for data center owners and operators that serve the financial sector?
Yeah, managing volatility. The speed of that business is increasing. So data center operators have to manage that volatility, increase speed, decrease time to market, and work with an increasingly recursive flow of information. Data centers used to only be about, I need capacity. Let me get capacity, and then I go ask for money, whether it's internal or I'm getting a contract somewhere. Money and capacity are no longer the only pieces of information that now flow back and forth in this particular ecosystem or life cycle. It's now becoming about density and time to market and resiliency and variability across the enterprise. And we're trying to get all those different pieces of information that affect the decisioning strategy and how people do and what they do and when they do it. We're trying to make all that happen on an ever increasingly faster basis. Managing that volatility is really going to be the key thing for the operators to get through. And unfortunately, as I've said for years, we can't pick up the data center and move it 10 feet west. So we're talking about a very large physical asset. It does take time to construct. There's a lot of embedded energy and work effort into putting it in place. Getting it wrong is becoming increasingly expensive because workloads are moving that much faster around us.
Mm-hmm. So do you think this focus on modularity in data center build-out recently is going to help that along?
Modularity is one of the big keys to this, but different people mean different things by modularity. To some people, modularity means containers. To some people, it means modularity in the distribution side as opposed to the gross supply side. Modularity has a lot of different components to it, and one of the ways we think about this now is, how do I build modular resiliency structures? I can think about a physical space or delivering some KVA or BTU into a given area as being one of the aspects of modularity, but why can't I have a multi-tier facility and I can actually treat upgrading a given zone or space within a data center from tier 2 to tier 3 or tier 4 or whatever you might want? Why can't resiliency be a module that I bring on and offline as necessary? So modularity is a lot of different things to a lot of different people, but it absolutely is one of the keys to the puzzle. Reducing workload, increasing flexibility, again, more keys to the puzzle.
Has there been much of a change in the way financial data centers are designed over the past couple of years?
Yeah, a lot. If we go back to 1995 to 2003, when we built financial data centers, some of the numbers changed. Resiliency's crept up from tier 2 to tier 3 to tier 4 and then back to tier 3. Density's crept up from 30 watts a foot to 50 watts a foot to 100 watts a foot, and in some extreme cases 250. So the numbers have moved around a little bit. But from 2003 to the present day, what's really changed is this idea that one size no longer fits all. I'm not going to have one operating density. I'm not going to have one resiliency profile. I'm going to have segregated workloads. And inside the financial services, the idea of getting to a single facility that gives me multiple levels of resiliency, so I can have discardable workloads running at a tier 2 kind of resiliency with highly critical ones running at tier 4. The ability to flip back and forth between those, bring that resiliency on and offline, and then getting into the workload side and understanding how we can segregate that workload. For example, if you look at many of the online retailers, much of their workload is stateless, which means I can put out many, many engines doing essentially the same thing. Once I've got multi-instantiation of stateless engines, I don't need to protect them. I can let them die. It's sacrificial workload. The workload just goes a resubmit, goes to the next engine. We move on from there. Putting that in tier 3, tier 4 makes no sense at all. So as my workload is going to shift and change, moving from stateful to stateless, and I alter the way I manage my persistence inside the data center, those are the only two things I need at a tier 3, tier 4 level. Everything else I can do through reinstantiation if I need to, and I can drive down cost, I can drive down time to market, and I can increase the variability of my portfolio. That's the kind of decisioning you're starting to see in financial services data centers today, and that's making a massive difference in what the actual box looks like as we construct it.
Currently, much of the overall data center industry is concerned with driving down the cost, obviously, to build a data center and shrinking the time it takes to build one. Are these concerns as prevalent in the financial services space? And if they are, what is the average cost per megawatt, and what is the average time to market in the trading sector?
So one, I hate those numbers. I absolutely despise the average cost per kW, but there is one. It's 22K per kW, basically, is the standard metric number you can work with. But like many averages, the most interesting thing about the average is that no one actually experiences the average. Everyone actually winds up coming in high or low to that number. But it is kind of an average that's out there. That's 22K per kW and about 2 years to deploy. We think that number should be more like 16K per kW and 6 months to deploy. And that is feasible. You can do it today. You just have to be pretty focused on doing it. Moving that number down even farther is really where we think it's at, because what we do when we can shorten that time cycle is we reduce the time between commitment to delivery. And as we shorten that life cycle and we get the provisioning capability of the data center closer to the business cycle that it's supporting, we increase the extent to which it is a better fit, and we're carrying less inventory or capacity in the portfolio. And to us, that's one of the key things, is how do we avoid carrying unnecessary capacity that really is just sucking up the balance sheet. It's creating a massive drain in both the operating profiles and the operating expense profiles of the organization. To do that, again, we're going to return back to modularity. We're going to turn back to workload characterization, understanding what my future is going to look like in some way, and then understanding how I'm going to embed the flexibility to deal with the unexpected. The unexpected merger, the unexpected financial downturn, whatever the unexpected might be.
What are the key elements that distinguish leaders in today's world of financial services data centers from the weaker players?
Two things. Integrated real estate and IT when it comes to managing data centers. One of the things that we worry about a great deal is what we think about as the information inside the information loop. And traditionally what's taken place is that we have two players, the IT side and the real estate side. And the IT side is expected to throw some requirements over the transom, and then real estate will go off and effort away against those. A much more effective way to do this is to realize that the requirements are actually interrelated, and one decision on the real estate side has an impact on IT and vice versa. And we can't just build a set of requirements. That always leads to overbuilding. We have to develop those requirements collaboratively, interactively, and it has to go back to the theory of operations of how you plan to manage the site once it's operational. So integration of the IT and FM sides for the data center is the first piece. The second piece is more on the IT side, and that's really about understanding what their workloads are. It is astounding how many of these financial services enterprises, big, massive, global spanning enterprises, have a very poor view. They can see through a glass and only darkly at that they can see through glass and only darkly at that what the actual flow of the business process is across their environment and how all the different pieces fit together. The firms that really understand that well and can make decisions and then execute against that, those are the ones that stand out. And they stand out by being faster in the marketplace, spending less per unit to get delivered what they want, and most importantly, this is one people miss, consuming fewer units. So when we come back and look at things like virtualization, one of the things that's happened is it's greatly speeded up time to market, but it's made a server instance almost free. Well, one of the things that then produces inside the organization is what we call instance sprawl. The same way that when we first moved off the mainframe to open systems and there was suddenly a server under everybody's desk, now we have virtual instances all over the enterprise. We don't know where they are. We don't know what they're doing. firms that can get on top of understanding what their compute strategy is, have an articulated, clear, concise compute strategy that actually maps into what their business process is, that they can then use to decision the data center side, those are the ones that really stand out from our perspective.
James, thank you very much.
Thank you, Evgeny. Appreciate it. Cheers.